Okay, so let's go over hexadecimal just a little bit more. So the key thing here is, let's assume we have a number in binary, 1010. In decimal, we know that's the 8 position, that's the 4 position, that's the 2 position, that's the 1 position. We add up 8 and 2, we get the number 10. But we also know in hex, that's the letter A. So how do we take this and go back and forth? How do we take a decimal number and convert it to binary? How do you take a hexadecimal and convert it to binary? So let's work on decimal first. Let's say we have the number 205. How do we take that and convert it? So what I do is I go back and I do my charts. 1, 2, 4, 8, 16, 32, 64, 128. Because remember, this is positions. So, I just do basic subtraction. Does 128 go into 205? Yes, it does. And that should leave 77 remaining. Does 64 go into 77? Yes, it does. That should leave 13. Does 16 go into 13? Or sorry, does 32 go into 13? No. Does 16 go into 13? No. Does 8? Yes, it does. Does 4 go into 5? Yes, it does. Does 2 go into 1? No. Does 1 go into 1? Yes. So our binary number for 205 is 11001101. Now how do we take this and put it into hex? Again, we're going to break it into two 4-bit sections, and we're going to do those conversions. So this is the 1, 2, we're going to add a 4 and we're going to add an 8. So that's 12. So what is 12 in hexadecimal? Well, A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. So this is going to be 8 plus 4, which is 12, so this is going to be the number C. This number is going to be 8 plus 4, 12. We're not adding the 2, we're adding the 1, so this is going to be the number 13. So 205 in decimal. In hex, it's CD, and in binary, it's 11001101.